This video is an introduction to logarithms. So the definition of logs is a to the power of y is equal to x. And this can be rewritten as log base a x is equal to y. So if we have a look at an example, let's say we take 2 to the power of 3 is equal to 8. Well, the 2 represents the a, the 3 represents the y, and the 8 represents the x. So if we're to rewrite that, we're going to have log with a base of 2, because that was the a, 8, because that was the x, is equal to 3, because that was the y. And what we can do is use the scorpion tail method to explain this. So let's say that we start with the base. So whatever the small number is beside the log part, that's what we're going to start at. And we're going to draw a scorpion tail, and we're going to wrap it around the number at the end, and we're going to end up pointing it towards whatever represents the x value. So we can say 2 to the power of 3 is equal to 8. So we start with the 2, and then going along our scorpion tail, we next pass the 3, then we pass the equals, and we end up at 8. So 2 to the power of 3 is equal to 8. And 2 to the power of 3 is indeed equal to 8. So they mean the same thing. So log base 2, 8, is going to be equal to 3, because 2 to the power of 3 is equal to 8. We start at the base, we wrap the scorpion tail around the number at the end, we go past the equals, and we end up back at the x value, the 8. Okay, now if we want to actually evaluate logs, there are 3 steps. Step 1, let the log be equal to x. Step 2, write the log statement in index form. And step 3, solve this equation for x. So let's say we want to evaluate log base 3, 9. So step 1, let the log be equal to x. So we're going to let log base 3, 9 equal x. And we want to rewrite this similar to our very first step up here, our definition of logs. So we want a to the power of y is equal to x. So we want to rewrite this in that format. So we're going to use the scorpion tail method again, and we're going to start with the base, which is 3. We're going to wrap the scorpion tail around the x, going past the equals, and end up with 9. So 3 to the power of x is equal to 9. So 3 to the power of x is equal to 9. Now all we have to do is rewrite the 9 with a base of 3, which is going to give us 3 squared. And then we can cancel out the 3's because the bases are equal, and we can equate the indices. So it's just going to be x equal to 2. In our next example, we want to evaluate the log base 8, 32. So step 1, let the log be equal to x. So log base 8, 32 is equal to x. Step 2, write the log statement in index form. So we're going to again start at the base, which is 8, wrap our scorpion tail around the x, pass the equals, and end up at the 32. So 8 to the power of x is equal to 32. 8 to the power of x is equal to 32. And then step 3, we just have to solve this equation for x. So we're going to rewrite the 8 as 2 cubed. Very important that we put brackets around it, and raise it to the power of x. And this is going to be equal to 2 to the power of 5, because that's what 32 is, as a base of 2. Now I am raising a power to a higher power. My rule is I multiply my powers. So 3 multiplied by x is 3x. A number times a letter, we stick them together. Now I have 2 to the power of 3x is equal to 2 to the power of 5. My bases now are matching, so I can cancel them out. Bring down the 3x, bring down the equals, and bring down the 5. So I need to equate my indices. Now I just solve for x. To get the x on its own, I'm going to divide across by 3. So x is going to be equal to 5 over 3. So log base 8, 32 is equal to 5 over 3.